Okay, so here is the scenario. We have a book, right? The story book. It has six stories, and I like to ask a question from these chapters to OpenAI and get the answer. Now, this is similar to, let's say, in your organization, you have corpus of multiple documents, and you would like your users to ask the question, and then you want OpenAI to answer those questions based on the content in those documents, right? So first let's try this, right? So I have already created the text out of these PDFs, and this is the question I want to ask. Why do the boys return the horse? Right? So it doesn't work. And this is the main problem that we have to solve. What it is saying is that the limit on the API is 4,000 odd tokens, but I am sending 24,000 tokens. Now the tokens are nothing but it's around the words. For example, if you have 100 words, a rough estimate is that 75% of that will be the number of tokens consumed. So what it is saying that the text in these particular documents, when you put them together, it totals or adds up to 24,000 tokens. So obviously I can't do that, right? The way I'm trying to solve it. So now the solution in this case is one of the solution that I've used here is the embedding. What we have to do is we get these documents, the PDF documents that we have, and we split them and extract the text out of it. Now, why do we have to split them is each document may itself be very large, right? So, for example, if you want to send a document on itself to OpenAI, it may not work always, right? So, some of the document itself may be very large that you would like to split them. For example, in this case, one of the story is about 22 pages long. So if the question is from this one, I won't be able to send this chapter as a whole to OpenAI to get the answer. So what we need to do is we need to have some logical split for the document as well. So in my case, what I've done is I've created a split for each page. You can maybe choose, let's say, 1,000 words for each split. Depends on whatever you want to choose. Once you've got the splits, we can create the embedding. Now the embedding is an interesting concept. It's nothing but it's a numeric representation of the text that you have, and the vector length is based on the model that you have used. So for example, in my case, the model is embedding model that I use the QnA. It gives you a vector of 1536 long length long, right? So once you have created this embedding for all the documents or all the splits that you have, when the user sends a query, you create a similar embedding for the query as well, and then you try to identify the vector similarity between these two corpus, right? So one is the query that you have, and another is your document corpus, right? The embeddings that you have created for all the documents. Based on the similarity, now the similarity is, it's a numeric number that you have that you can sort on. So the highest number will represent that this particular query maybe belongs to these two documents out of this whole corpus. Once you have identified that, you may choose to send the top matching documents only or the top matching splits to the OpenAI. Right? So for example, in my case, I am sending three documents, 3 pages to OpenAI based on where the match exactly is. Right? So let's try this. So this time when I am asking a question, I'm not going to send the full chapter or the full book. I let it identify where the where the answer most probably lies, and then it will create a context and then send it to OpenAI. So let's just do this. Right. So this time I get the answer. The boys returned the horse because I'll let you read this. Now the way it works is if you see it behind the scenes. what I've done is each page has got a text as well as the embedding associated, and then we calculate the similarity for these, right? So this particular question actually belongs to the horses chapter, and you can see that top 5 documents or the pages that it identified the embedding belong to this particular chapter only. So what I'm doing is I'm sending the pages which are around the top match. For example, in this case, the page number 8 matched. I'm sending page number 6, 7, and 8 to OpenAI. Right? So we can try another question. For example, so let's do this last one. In this case, you see, it belongs to this Melon chapter. It's actually the name of the story is Melon City. And you see, all the matches are coming from this, right? In this case also, I'll be sending 3 matches, 4, 3, and 2, or maybe 5, 4, and 3. And then we send this, right? Yeah, and then I'll let you read this. How did a king met his fate? So this is the one thing. Another which is really important for you to know is that this time the request that we are sending had, let's say, 672 tokens only. The earlier request that we had sent had 1,000 tokens, right? So we are now not sending 24,000 tokens earlier, right? That we were trying to send. Now we are, sub 1,000 tokens that we are sending in our request. Now the important point here from the token perspective is that your pricing is also based on the token. So if you are efficient with what the context that you're sending to OpenAI, you will save on the cost as well. So I leave it at that. Rest of the details are in the blog, and you can read the blog. Rest and the code is there on the GitHub as well.